Okay, so we're going to be solving trigonometric equations using the identities that we know. So we have solve 2 secant squared theta minus tan to the 4th theta is minus 1. So I'm going to rewrite my equation just here. And I'm looking to see where I can replace. Now I know that I have a secant squared theta, and I can replace this. So replace secant squared theta, and this is equal to 1 plus tan squared theta. So I'm left with 1 plus tan squared theta minus tan to the 4th theta is minus 1. And I'm going to distribute, so I'm going to have 2 times 1 is 2 plus 2 tan to the squared theta minus tan to the 4 is minus 1. I'm going to rearrange, I'm going to bring everything onto one side, so I'm going to add 1 to both sides. So 2 plus 2 tan squared theta. So we're going to do plus 1 and make it equal to 0. Now I have a 2 and a 1. So I have 2 tan squared theta minus tan to the 4th theta plus 3 is equal to 0. Now I'm going to multiply this by minus 1. So I'm going to have tan, so I'm going to multiply by minus 1. So I'll have tan to the 4th theta, and I'm going to rearrange. So minus 2 squared theta minus 3 is equal to 0. And I've done this so I can factor. So I'm looking for factors of 1 times minus 3. So I'm going to factor a minus 3 with a difference of minus 2 is going to be minus 3 plus 1. And I have a tan to the 4 and a tan squared. So this is going to be tan, so this is like my tan of x. So if I was to rewrite this as tan squared theta minus 3, and I want a 1, so I'm going to have a tan squared theta plus 1, and this is equal to 0. So I'm going to take both equations. So I have tan squared theta is equal to 3, and I have tan squared theta is equal to minus 1. Now because this is squared, we're going to take the square root. So tan of theta is going to be plus or minus root 3. And this is going to be tan to the minus 1 of root 3. So this is going to be 60 degrees. Now it can also be minus, so it can be minus 60 degrees also. So let's say this is plus 60 and this can be minus 60. And then our tan, so we have tan squared is plus or minus the root of minus 1. Now we know that tan has no solutions. You cannot be negative. You can't take a negative root. So no solutions for tan minus 1. Now this will repeat every 180 degrees. So this is going to be, should we have minus 60? So this is minus 60 minus 180. So we'll also have minus 240. And 60 plus 180, we'll also have a value at 240. And this will continue to infinity. Okay, so 2 questions. So the first one is 2 cosine theta equals minus 1. And is theta is measured in radians? So you can pause the video and have a go. So we need to rearrange. So this is 2 cosine theta. So we're going to do cosine theta is minus 1 divided by 2. So that's going to be cosine theta is minus a half. So when cosine theta is minus a half, this is when theta is at 2/3 pi. And we have a cycle that repeats every 2 pi or every 360 degrees. So the solutions, so we have 2/3 pi, and this would be minus 2 pi, and we'd have 2/3 pi plus 2 pi. So this would give us with minus, so we'd have minus 8/3 pi and 2/3 pi. And we'd also have, on the positive, we'd have 8/3 pi. And this will continue. So a different example. So solve 2 cosine squared theta minus 1 equals sine theta. If theta is greater than or equal to 0 and less than or equal to 180 degrees. So if we look at our equation, we need to replace what we can use in identities. So if we look at, we have a 2 cosine So 2 cos squared theta is, we can replace with this 2 cos squared theta. This is equal to cosine 2 theta. So this, I can write this as cosine 2 theta. And we'll keep sine theta the same. So I'm going to replace now my cosine 2 theta with one that contains sine. So that's 1 minus 2 sine squared theta. So 1 minus 2 sine squared theta. I'm keeping the right hand side the same. So I'm going to bring everything over to one side. So I have 1 minus 2 sine theta minus sine theta. And I'm going to make this equal to 0. So this is a 0 property. And now what I can do is factor. So I'm just going to rearrange this and factor. So, right, actually I'm going to multiply by minus 1 first. So we'll have, this will be minus 1 plus 2 sine squared theta plus sine theta is 0. And then if I rearrange this, so I have 2 sine squared theta plus sine theta minus 1 is equal to 0. And now I'm going to factor. So I'm going to factor, and if I look at this in the form of 2x, and this is 2x squared plus x, and this is minus 1. So I can factor, and I'm looking for factors. 2 times 1 is 2, so it's minus 2. Factors are minus 2 with a difference of positive. So it's going to be a minus 2 and a plus 2 and a minus 1. So if I was to write this, we were using normal algebraic terms, I would say 2x squared plus 2x minus x is minus 1x, and then I have minus 1, and then I would factor by 2x. So 2x, this would leave me with x plus 1, and then I can factor by minus 1, which would leave me with x plus 1. So this would be 2x plus 1 and x plus 1. So writing this into instead with signs, this is going to be 2 sine theta plus minus 1, that should be. That's a minus there. So 2 sine theta minus 1 and sine theta plus 1 is equal to 0. Now I can take my equation separately. So 2 sine theta is equal to 1 and sine theta is equal to minus 1. So I'm going to divide by 2, so we have a half. So let's have a look at our values. So this one is, our values are between, so in the question says our values are between 0 and 180 degrees. So sine theta is a half, and we're working in degrees, so answers in degrees. So this is when theta is 30 and 150. This is in the range. And also over here when sine theta is minus 1. So our values need to be between 0 and 180. So this is only when theta is 270 degrees. But this is out of range. So this one is fine, and this one is not fine. So our solutions will be 30 and 150.